Hi, my name is Advik, and today we're going to be looking at maximal value from atcoder beginner contest 468. We're going to go through a step-by-step solution for this. Okay, so let's get started. Here's the problem. So here we can see the title, maximal value, and we can see the problem statement. You're given an integer sequence of length n, and then you're given the integer sequence. This can be uh, like represented via a C++ vector, and we're gonna see how we can do this later on in the video. Our task is to find the number of integers I between 1 and n minus 2. So these are the indices that we need to iterate over. They literally just give us the bounds, the lower and upper bound. And we need to satisfy this condition. So it's, say we have a subscript I here. We have subscript I plus 1 for the next element, and then I plus 2 for the other third element. The middle element has to be greater than both of these. I like to imagine the alligator and its mouth. You can see that the alligator's mouth faces this way, kind of like an elementary school analogy, but it gets the job done. We don't really need to worry about constraints for this problem. It's pretty much a simple for loop iteration. All right, so we're going to look at the input. The input's just going to be a standard CN, and let's look at an example. So this is mainly just to look at any edge cases. Doesn't seem like there will be, but we're going to try anyways. So in this case, 6, this is our n. So this is the amount of elements that we're going to have to input into our vector. We can see these are the numbers, sorry. So let's start off. First element's 3. We don't start with this one. We start at element of index 1, which if you know standard indexing, the first element is 0, second element is 1. So we start at 1, which the element at index 1 is 1. So we start at 1, we look to our left, we look to our right. It's not greater than either of them, so we immediately move on to the next one. Let's move on to 4. 4, we look to our left, we look to our right. 4 is a maximal value. So we we increment our variable that keeps track of our amount of maximal values. And then we move on to our next one. So we move on to 1, we look to our left, we look to our right. 4 and 5 are greater than 1, so this doesn't work. We move on to 5. 5, we look to our left, we look to our right. 1 is less than 5, and 2 is less than 5, so we stop right there, and we increment once again. So we have 1 from this 4 element, and then 1 from this 5. 1 plus 1 is 2, so our answer is 2. We don't do this last one, because we don't have anything to the right to compare to. And then the same thing for the first element. That's why we were given these bounds. If we try and access something outside of this, we're going to get unexpected behavior, and that's not what we want to do. So that is the problem. Pretty straightforward. I'm going to let you try it out on your own before I show you the solution in code. All right, so let's get started. The first thing we need to do is we need to include the vector library within our environment. So we do this by this header, and that's really the only setup we need to do for this problem. Let's look back at the problem statement. We need to cin this length, which is input, so we're going to input this length. Let's see, we're going to do int n, and then we're going to do a cin, in this case standard cin n, and let's just do this on a new line for formatting purposes. Let's move on to our vector, which is a, right? This is a container for all of our values. So we're going to do standard vector, and we're going to give it a data type, int, and we're going to call it a, and we're going to give it a size n. So this is how you define a vector, or initialize a vector, within C++. Now, we're going to have to fill in all of the values here into our vector. So let's do that next. We're going to do for int I equals 0. We're going to go until the end, or until the size of the array, or vector, which is n, and we're going to increment along the way. And we're going to cin a subscript I. Notice that in this case, we're using parentheses to define the size, but in this case, we're using the square brackets for access operators, so we're accessing each individual index and we're placing the value into the index. So now we've gotten all of our values inside of our vector, and we need to apply the core logic. So let's do that now. So let's do another for loop. We know the bounds, 1 and n minus 2, and we know why these make sense. So we're going to just plug them in. Just a quick correction, since we're tracking the middle value, we go from index I equals 1 to n minus 1, instead of I equals 1 to n minus 2 instead. With the latter, we would actually be missing one element in the vector. Notice we can use I here again because I is only defined within this local space of the for loop, and we can reuse I after this. So now all we need to do is just apply this, and we need to set up a count variable to keep track of this. So we're going to set count, a count variable. We're going to initialize this to 0, and I'm going to tell you why we need to initialize this to a specific, we need to declare it as equal to 0 rather than just initialize it and give it a garbage value. This will be very important later. So for int I equals 1, I is less than n minus 2, I plus plus, we're going to look at, in this case, I we're going to essentially compare it with its neighbors. So let's say we have 5, 4, 3, 2, 1. 1 will be this, and we compare it left and right. So we need to do if a sub I minus 1 is less than a sub I, and then we're going to add another condition, and a sub I is greater than a sub, we're going to look to our right, a sub I plus 1. And yeah, we're going to increment our count variable. And then all we need to do is see out or output our count variable. So let's do that. Let's not return. Actually, let's keep that there. And I'm going to, just check everything real quick. And this should work. We're iterating over I here in this case. Yeah, everything looks good. All right, cool.